Welcome to the HGST Channel Marketing webinar, Build Your Cloud Storage Opportunities. Today, we will uncover how storage plays a critical role in the cloud, what drives storage selection, and how HGST products can help optimize data centers for cost, performance, and capacity for lower customer TCO. A few housekeeping notes to begin. As you enter the WebEx console, you will notice that this event is being streamed through your computer speakers via the WebEx Media Player. Please keep the WebEx Media Player open at all times. If you had to join via the teleconference, please note your phone lines were automatically muted and they will remain this way throughout the webcast. We will be using written Q&A during today's event. To ask a question at any time, please enter your question in the WebEx Q&A panel as you think of them. You can find the Q&A panel at the bottom right hand of the console. If you are in full screen mode, it will be located at the top of the screen to the far right on the arrow and select Q&A from the drop-down menu. Please leave the WebEx chat window for communication to our WebEx facilitators for problems or issues you may be experiencing. Again, please enter your questions for our speakers in the WebEx Q&A panel. Today's program is being recorded and will be available for viewing. At the end of this session, there will be a short survey that will pop up when you close your browser. If you could please take a minute to complete the survey, we would greatly appreciate it. At this time, I'd like to introduce Mike Alazenko, Senior Director of Cloud and Mobility, and Clint Ludeman, Senior Product Line Manager, Enterprise Storage. Mike and Clint, I'll turn the program over to you.
Thank you. Hi, I'm Clint, and I'm excited to be here with Mike today. First off, let's talk about HGST. HGST is now a Western Digital company. Under regulatory terms of the acquisition, HGST is being run as a completely separate company. HGST products are found in the world's leading desktops, notebooks, and data centers. We believe our success comes from having the highest reliability in the industry and the right mix of products. And of course, we have fantastic customers and partners like those of you tuning into this webinar today. Our products stretch from the enterprise to the client. Enterprise UltraStar products include both capacity and performance hard drives, as well as SSDs for the ultimate performance boost. Client compute, we have both our TravelStar and DeskStar product lines. And for the consumer markets, we have our G-Tech personal storage products and the CineStar drives designed for CE applications. Today, we're going to focus on the enterprise class storage, which is perfect for cloud customers. The cloud is driving change in storage solutions, which in turn is creating new business opportunities for all of us. Cloud solutions require high capacity storage as well as performance, and at a very large scale. As you scale up, the total cost of ownership, or TCO, becomes a key factor in delivering high quality and cost-effective solutions. Mike, can you tell us and take us and show us how the cloud is creating opportunities to use our products in new applications?
Thanks for the great introduction to HGST, Clint. Before we jump into cloud storage, I'd like to review some of the basics of the cloud. Cloud is a common term today and one that is often misused. At its essence, the cloud is about creating efficiencies through optimizing the data center. This is accomplished by improving server, storage, and network utilization. In traditional IT environments, server and storage resources are often dedicated to a particular function or group within the company. One group may find themselves with more than adequate resources, while others may constantly be running out of computing cycles or storage, requiring upgrades and expansion. Because of the siloed nature of many IT infrastructures, underutilized resources may remain underutilized in IT islands. Through technologies like resource pooling and virtualization, the basic building blocks of a cloud emerge. Sharing, multi-tenancy, and the ability to track usage and build departments for server and storage usage allows data centers to run closer to full capacity, providing better ROI. With respect to storage, there are two basic types of cloud storage: storage in the cloud and cloud storage. Most of the time we use the term cloud storage for everything, although they are very different. Storage in the cloud goes hand in hand with cloud computing. This is where the application, the data, the compute, and storage all reside in the cloud. Like traditional IT environments, storage in the cloud is often built with a variety of types of storage, ranging from SSDs to high-capacity hard drives. Startups will often build their entire IT infrastructure in the cloud using this type of storage, and businesses that have rapid growth or seasonal workloads may use this model as well. More commonly, we will find email, online sales tools, social networking, and the like using both cloud compute and storage in the cloud. Cloud storage is the other model for storage in the cloud. In this model, the application or server is separated from the data across a network or the internet. The cloud essentially becomes another layer or tier for the user or data center. This model is most often used for archiving or backup by consumers as well as the enterprise, where latency is less of a concern. This type of cloud storage is typically built with the highest capacity disk drives, where dollars per gigabyte is critical. There are several types of clouds, and they can be in a number of places. To be considered a cloud, server and storage resources are always accessed across the network or the internet using a browser or an app. It is somewhat similar to the client-server models we've seen in the past. IT organizations may evolve their traditional data centers to a cloud data center by virtualizing and pooling resources and providing mechanisms to measure and bill for usage. When all the resources and storage are still owned and managed by the IT department, we call this a private cloud. The private cloud improves utilization by eliminating silos or IT islands, but it's still costly as the IT department continues to purchase and maintain all of the equipment. Private clouds are usually on-premise, but can be multi-site using co-location facilities to improve performance and accessibility. On the other end of the spectrum, we have the public cloud. This is where storage and compute become a service. It's off-site with multiple data centers owned and managed by a service provider. It's the most flexible and lowest cost IT solution as resources are shared across multiple companies and users are typically only charged for the resources they use. At HGST, we believe that most companies will deploy a hybrid cloud. The hybrid cloud isn't a third type of cloud, but a way to combine the benefits of both the private and public clouds. Users of the hybrid cloud place some of their data and applications locally in the private cloud and place other data or applications in a public cloud. The hybrid cloud improves costs like a public cloud, but keeps things under IT control with higher performance like a private cloud. It is also most beneficial for companies that have seasonal or variable workloads using a public cloud for tasks and data that overflow their private cloud. Hybrid clouds can be the most complex to deploy, but also create a broader set of opportunities for server and storage suppliers. All three types of clouds are driving opportunities for a variety of supplier types. Beyond our traditional customers, we see a rich mix of businesses building and deploying storage in this cloud era, taking advantage of the unique demands and requirements of the cloud data center. System integrators, do-it-yourself IT departments, new cloud service providers, and co-location providers adding cloud services are all looking for optimized solutions and alternatives to how they acquire servers and storage. The hybrid cloud is also creating new opportunities through NAS appliances and cloud gateways that seamlessly move data between private and public clouds. This is an emerging opportunity for system builders with only a few players so far. The best opportunity for your growth may be in creating and supporting solutions that enable the hybrid cloud, as well as targeting the high growth of companies building public cloud services. This can include pure cloud services, online gaming, content delivery, storage, and many others. The cloud and massively scaled data centers are disrupting traditional storage architectures, partnerships, and ways of doing business. This disruption creates several leverage points for you and your customers. With this growth, storage has moved from being a necessary commodity to a key part of the data center as a broader set of applications and customers create, store, analyze, and stream more data than ever. No one seems to have enough capacity anymore. Data replication, common in the cloud, makes multiple copies of data across multiple servers and multiple geographic locations, driving even more capacity growth. To address this growth and scale, many cloud service providers are adopting or investigating alternate storage and server architectures and sourcing models. Operating systems and applications are often based on open source software, creating opportunities for you and your customers to differentiate your products and to move quickly. Rather than use general-purpose servers and storage, these new systems are often streamlined for specific applications and to the unique environmentals of a particular data center. These customized servers and storage solutions are produced by a broad set of suppliers and often as not are designed by the cloud data center engineers themselves and built by ODMs and system integrators to get exactly what they need. The last change in the ecosystem is TCO, or total cost of ownership. We'll talk more about TCO in a few minutes, but behind many purchase, planning, and design decisions is how to manage and improve total cost of ownership. Servers and storage are becoming optimized not only for particular applications or uses, but for improved density and other total cost of ownership benefits. For example, depending on the data center and application, we see server configurations with 4, 12, 45, and even up to 72 disk drives. We've been seeing a shift from block storage to object storage and broader deployments of replication versus RAID systems to address the increasing rebuild time and concerns over data loss. This changes the type of storage solution being deployed in the data center, with more consideration being given to performance, power consumption, and reliability. One of the myths about the cloud is that it's all built on low-cost desktop disk drives. While some cloud service providers have deployed this class of storage, most are using a tiered approach with a broad variety of capacity and performance points ranging from SSD through 10K RPM and high-capacity disk drives. While many deployments use SATA today, SAS is becoming more broadly used for its improved connectivity in high-density solutions and for its richer protocol, as well as to deploy SSDs and high-performance disk drives in the same systems. Many cloud service providers use open source software and are experimenting with low-cost processors and alternative hardware. This fast-moving ecosystem enables more differentiation opportunities for storage and server suppliers. To summarize, the cloud is built on a variety of optimized platforms, broadening the opportunity for your products, services, and customers. Earlier, we introduced TCO, or total cost of ownership. In our next webinar, we're going to focus on how you can use TCO as a tool to grow your business, but let's take a quick look at TCO right now. Before we get started, if you look at the right side of your screen, you'll see our first polling question about TCO. Historically, storage purchases were based on capacity, time to market, availability, and cost. Some attention may have been given to features, but they were secondary as multi-sourcing requirements minimized their value as a differentiator. The shifts in the ecosystem we discussed earlier, coupled with the hyperscale data centers and data centers becoming P&L centers, IT managers and cloud service providers are constantly looking for new ways to control expenses. This has led to a shift in storage buying criteria. Features like performance tuning, security, sanitize or secure erase, and having a broader selection of disk drive performance classes creates value for the data center designer. But most important aren't just the costs associated with acquiring servers and storage, but with running those devices over their useful life. Raw storage pricing is giving way to TCO, creating several new metrics for disk drives and storage. TCO is becoming a greater part of the decision-making criteria in selecting disk drives and storage solutions for most large-scale and cloud data centers. Before we introduce these new metrics, let's take a look at why TCO has become so critical. Working with some of our customers and partners, we've been developing a TCO model for large-scale data centers and businesses using co-location services for their cloud offerings. With this data, we can better understand the types of products HGST should be designing and how to better service our customers. Depending on the size of a data center and whether a cloud business has its own data center or is using a co-location facility, we find the split between capital expenses, or CapEx, and operational expenses can vary significantly. Companies using a co-location facility to host their cloud businesses can see their OpEx approaching or exceeding 50% of their costs, whereas a company with a hyperscale data center may see capital expenses approaching 60 to 70% of spending. Within the CapEx or capital expenses category, servers and storage, including the hard drive and SSD components, make up the bulk of the expenses. Floor space and infrastructure is often a smaller share for data centers, as it's typically amortized across a longer period of time than servers, so its impact gets diluted. However, when using a co-location facility, floor space rental can be a third or more of operating expenses. Data center location plays a critical role in the cost of floor space. On the OpEx or operational expense side, power and cooling accounts for the majority of spending, with bandwidth being significant for many cloud companies. Depending on the business, bandwidth costs may be passed on to the customer. Focusing on server and storage TCO enables new value-add opportunities and differentiation for you and your customers. Let's take a look at the TCO metrics that can help address both capital and operational expenses. Cloud service providers and cloud businesses are constantly looking for ways to improve their costs and therefore improve their bottom line. In our next webinar, we'll look at each of these metrics in more detail and share some use cases with you. But because TCO has become so important, we wanted to share some of the concepts today. As we saw on the previous slide, the cost of power and cooling is usually the largest operating cost a data center has. When considering solutions, you can't just look at the power consumption of a device, but also how much power it takes to cool the same device. Solutions with low power consumption and reduced cooling needs translate quickly to real dollars. Metrics like watts per terabyte and BTUs per terabyte begin to emerge. High-capacity disk drives, like our 4 terabyte product, coupled with high-density servers, improve storage density, reducing both operational and capital expenses. Terabyte per square foot and terabyte per cubic foot are terms we are starting to see used. With higher capacities, your customers can lower their TCO in terms of floor space, cooling, networking, and many other factors. Weight has also become a consideration. Cloud and large-scale data centers can find themselves in a variety of places beyond a slab of concrete in the Midwest. Modular data centers with stacked containers, portable data centers, and data centers on the 37th floor of a 100-year-old office building are becoming the norm. System and rack weight become critical from a structural loading perspective, as well as for safety and to reduce shipping costs. Because the cloud and large data centers operate with high efficiencies and are typically around the clock, downtime is unacceptable. Highly reliable servers and storage systems are key to providing good user experiences and managing labor costs. The MTBF, or mean time between failure of a disk drive, can impact the OpEx of a data center very quickly. HGST's enterprise-class products provide a 2 million hour MTBF, minimizing downtime in both small and large storage deployments. We saw on the previous slide, service providers and data center builders are constantly looking at ways to reduce their capital expenses, particularly for servers and storage. Through high-capacity disk drives like the HGST 4 terabyte or high performance like our 10K and 15K RPM disk drives and SSD products, system designers can manage CapEx by building performance and capacity optimized solutions. This brings us to one of our last topics, storage tiering. We spent a lot of time with our customers and partners characterizing workloads for the cloud and enterprise. What we found is that typical applications fall into a continuous spectrum balancing performance and capacity needs. On one end of the spectrum, we find applications for high-frequency trading and real-time analytics, along with traditional database and OLTP applications where performance requirements are high, but storage requirements may be lower. On the other end of the spectrum, we find applications with stratospheric capacity requirements, but performance is secondary. Big data, content serving, cloud storage, and archiving drive this space. And in between, we find the storage in the cloud, gaming, and a variety of database applications. To provide the best match of storage solution to application with a keen eye on TCO, we at HGST continue to develop and expand our product portfolio to ensure you can offer the best balance of performance, capacity, and cost to your customers. Today, we have SAS SSD products that deliver the best IOPS per dollar and IOPS per watt for performance-hungry applications. We also offer a family of 10K and 15K RPM SAS disk drives that balances high performance and capacity. We also have our 7200 RPM SAS and SATA product family that provides industry-leading capacities and the best dollars per terabyte value. Two other segments on this chart are PCIe SSD solutions and a new category of product called cold storage. Extending the spectrum of performance and capacity, these new classes of storage will continue to drive IOPS per dollar and dollars per terabyte. Stay tuned for future updates as these market segments develop. If you look at the right side of your screen, you'll see our second polling question about tiering. And with that, I'd like to turn the program back over to Clint.
Okay, well, when deploying drives in a cloud environment, of course, it's important to consider how the drives are going to be used. UltraStar Enterprise drives are designed for harsh environments. This design point provides an MTBF specification of 2 million hours, which is the industry's highest specification. And statistically, a 2 million hour MTBF translates to 40% fewer expected failures over an enterprise drive rated at 1.4 million hours. And the difference is even greater over consumer-rated drives that are designed around 700 to 800K MTBF. And we back this up with a 5-year warranty. UltraStar drives are designed to be powered on 24/7, 365 days a year. It is also important to understand that a drive is designed to be accessed 24/7. On the other hand, a consumer drive assumes that the drive will likely be turned off each day where an UltraStar drive assumes a higher duty cycle than a desktop drive. Another difference is that the enterprise class drives are optimized for performance, with faster seek times than typically found in a consumer class product. RV, or rotational vibration sensors, are standard. An RV sensor allows the drive to maintain performance when multiple drives are placed in racks, and those racks are all spinning and producing rotational vibration. Many cloud application providers are concerned about securing user data. Bulk data encryption allows the drive to safely secure user data, and it provides another benefit by allowing hard drives to quickly be repurposed or even retired by a simple change of the encryption key. If you're looking for the most cost-effective storage, look no further than the UltraStore 7K 4000. This is a 4 terabyte capacity enterprise drive for nearline applications. By simply providing more terabytes in the same package, the 4 terabyte drive effectively increases your storage density by 33% over a 3 terabyte drive. With 4 terabyte drives, you can create a single 19-inch rack containing 2.4 petabytes, and that is a lot of photos. The larger capacity reduces the watts per terabyte by 24% over a 3 terabyte product, and even more savings can be found over a 1 or 2 terabyte product. The easiest way to reduce power per terabyte is to climb up the capacity curve and purchase the highest capacity available. And of course, additional power savings can be achieved by using the drive's advanced power management modes, if your application can take advantage of them. For anywhere massive amounts of storage are required, the 4 terabyte drive is the best way to reduce your long-term storage cost. If your application is compute intensive, you will certainly want to include one or more solid-state disks in the solution. SSDs provide ultra-high performance, reliability, and endurance. Performance and reliability are well understood with spinning disks. With SSDs, however, it becomes important to run your SSD benchmarks from within your application to truly understand the SSD performance characteristics as they are related to your application. Also, understanding SSD write performance's endurance is vital. Endurance is a measurement of how many writes can be done before the SSD wears out. As a technology trend, the market is moving from SLC to MLC flash technology. SLC offers the best endurance, but it is also more expensive to produce than MLC. MLC controller and technology improvements now provide better endurance, and many applications don't require the extreme write endurance that an SLC provides. In the field, MLC is proving to be a more cost-effective solution for many applications. In order to scale your application, UltraStar SSDs are designed to be plug compatible with our 10K performance hard drives. This will allow you to easily swap an SSD with a 10K hard drive, and this provides a great tiering strategy. SSDs provide the best IOPS per watt for reducing your total cost of ownership, while a 10K performance drives are more cost-effective from a dollars per gigabyte perspective. TCG security options are also available. When optimizing a cloud data center deployment, certain applications require additional performance. Moving to a 10K RPM drive is one way to solve this problem. It's perfect for frequently accessed data, such as indexes and metadata. This 2.5-inch drive spins at 10K RPM and provides 900 gigs of storage. Power consumption is low at 5.8 watts with a high-performance 6 gigabit SAS interface. Like our capacity drives, our performance drives also offer self-encryption models. Depending on the application, you can blend SSDs with performance and nearline drives to create the optimal solution. When working with your customers or your own solution, start by mapping the capacity and performance requirements using the familiar storage pyramid. Identify where the performance is needed. Then, segment the Tier 0 and Tier 1 layers between SSDs and 10,000 RPM performance drives. When large amounts of storage are needed, Tier 2 can be filled with nearline drives like the 4 terabyte drive. Today, nearline drives provide faster access than tape archival for longer-term Tier 3 storage. In the future, hard drives will be further optimized to provide the best dollar per gig per watt and reduce long-term storage cost, all without giving up the ability to be back online relatively quickly. So as a takeaway, Mike and I would like to leave you with 4 final thoughts. The first one is that cloud is driving a tectonic shifts in the eco-storage system. These technology, business, and product shifts can create opportunities for you.
Second, storage tiering is becoming more important to balance capacity, performance, and cost, especially in the cloud data center.
Third, it's no longer just what a disk drive storage solution or a server cost, but rather the TCO or total cost of ownership. TCO is driving decisions for IT managers and anyone doing large-scale deployments of storage to improve their bottom line.
And finally, HGST has a broad set of products and an experienced team to help you offer winning solutions.
So before we open up the floor for questions, we hope you found this webinar useful. And we'd like to invite you to our next webinar where we will show you how to differentiate and reduce the TCO with HGS products. We will now open the floor for questions.
And just as a reminder, if you do have questions, please put them in the Q&A panel and we will get to as many as we can. Thanks.
Okay, we have our first question, which is, what large cloud customers are you working with right now? And because of confidentiality, we can't actually name names, but our products are in use today at some of the world's largest social networking, search, content, and cloud companies. We're also working with a number of new entrants that will be tomorrow's leaders.
There's another question we got here is, many of our customers insist on using less expensive desktop drives. How can I encourage them to use enterprise class drives? Well, our customer experience has shown that putting a true desktop drive into a large rack of drives will only create problems. That's one of the reasons why we created the RV sensor technology, is to be able to maintain performance. So what will happen is not only will performance degrade with all the spinning drives and fans that are in the system, but desktop drives will often fail sooner because they're not built for that 24/7 always accessed environment. So we design in the RV sensors, for example, specifically to maintain system performance in large rack installations, and you'll only find those on the enterprise class drives.
Okay, we have another good question here, which is, how do you fight the fear in local and government for using the cloud? And actually, what we're finding is a number of government organizations are beginning to use the cloud. As we talked in the webinar, there is public clouds and private clouds and hybrid clouds. There's actually even some subsegments to that, some things called virtual private clouds and things like that. What we're finding is because of all the government organizations are fighting budget constraints, the cloud is an effective way for them to be able to get to lower cost, lower spending for IT, and to consolidate their resources. And in terms of fear of security, one of the things you have to think about is whether you're a small business, a large business, or a government organization, you have to make all the investments into internet security and communications security. Whereas if you go with one of the larger cloud companies, they're in the business of delivering security and cloud computing and cloud storage. So again, we're finding a lot of government organizations very rapidly beginning to adopt the cloud. That probably wasn't so much true a year or two ago, but it's happening now.
Okay, we had a question here about advanced format. Currently, the 4 terabyte drive is what's called an advanced format drive, which means it's a 4K native sectors and does 512-byte emulation. Currently, that's the only product we have. In the future, we will be looking at doing a 512-byte native version of the 4 terabyte product.
One question for clarification here. The question is, I believe you said that SAS controllers will do a mix of SAS and SATA SSDs. So I assume that a SATA controller will not do SAS. Actually, what we meant by that is there are a number of cloud data centers that are using tiered storage in terms of different performance types, performance classes of hard drives and SSDs. And by enabling SAS, it allows them to really kind of simplify the deployment of that versus having some systems being SAS and some systems being SATA. So it's not so much of mixing those things necessarily in the same box or on the same controller.
There's a general question here about availability of products due to the Thailand flood and people looking for different applications and wanting higher performance drives. And the question really is asking, do we see things ramping up for availability? And the answer is yes. The industry has gone through a pretty major hit with the Thailand floods in the fourth quarter of last year, but production is ramping up and we're starting to see more and more product become available, and I think we're really, as an industry as a whole, getting up to closer to 100% of where we need to be to supply demand.
We have a number of questions regarding the HGST and WD integration, product lines, and things like that, and I think what we'll do is we'll answer those offline just because there's just a tremendous number of those. One of the other questions that's come up, and by the way, we have a large number of questions, and I apologize we're not going to be able to answer all of them live today. One of the questions is, when will cold storage be available and what is it? So just briefly, what's happening with the cloud today and large data centers is there's become an increasing amount of data being collected, whether it's from surveillance cameras or it's from sensors or it's from log files that track a lot of the things that people do on the internet, or just a variety of data is being collected more so than ever before. And this data is analyzed and does predictive analysis and gives you a better experience. And again, you know, law enforcement and other agencies use a lot of this data that's being collected for surveillance, and that data needs to be on a disk drive because of being able to access it very quickly. However, what's happening is between the sheer bulk of the data and trying to find lower TCO solutions, we're being asked to develop a new class of storage. And so we're still in the definition phase of it, but it's really about kind of an archiving solution, deep storage, really ultra bulk storage with different performance characteristics. Again, if you have some needs or some of your customers are talking about storing, you know, bulk storage, tape augmentation sorts of solutions, we'd like to hear from you. As for when it's available, again, it's still within the industry itself, it's still kind of under definition. So stay tuned and we will definitely fill you in.
All right. So again, I just wanted to thank everyone for joining us today, and I would also like to thank Mike and Clint for presenting for us. Just a heads up, we do have another interesting webcast coming up on August 28th, Differentiate and Reduce TCO with HGST Storage. So make sure to get signed up for that so you don't miss out. Also, we are going to be drawing a winner for an iPad following the webcast. So for joining today, you do get a chance to win. Also a reminder, if you close your browser, a short survey will pop up, and if you could just take a minute to complete the survey, we'd greatly appreciate it. Again, thank you for your time today, and have a great day.